You're fine. Hello everyone, and welcome to another GIS mathematics tutorial video. And in this video, I want to wrap up our first example talking about points and polygons. And I want to sort of start off by recapping where we left off previously. So in the last video, we were trying to figure out whether or not this point P right here, right, whether P was inside of this polygon ABCD. And graphically, obviously, you can tell that it is, but how would a GIS system be able to do that? And we sort of started off with the first question of if we were to draw a box that encompassed the maximum and minimum of the x and y coordinates of the entire polygon, which in this case is the same thing as our actual polygon, right? Does P fall inside of that? And we did that by checking whether or not the x coordinates and the y coordinate of our point fell within the range of x min, x max, and y min, y max. And we did that check, and we found out that it does indeed fall inside of that bounding box, which means that we actually do have to proceed and figure out whether or not it's inside, right? Because if either one of these failed, we could have just stopped right there and known that it was not inside of the polygon. But unfortunately, they both passed, so now we have to figure out, okay, what do we do next? And the next point I sort of told you was that we can figure out if P is inside of the polygon by figuring out how many lines are to the right of the point, right? So how many lines are to the right of this point? And I said that we could take a little trick where if we make a horizontal line from point P to the x max coordinate of the polygon, or if we make a horizontal line that connects them, and we call this PQ, right, we can turn that question of how many lines are to the right of the point to how many lines does this new line PQ intersect. And we know how to address intersecting lines, right? We've already done this. So now what I want to do in this video is wrap this up by actually answering, okay, well, how many lines intersect PQ? So let's give ourselves a little bit of space here. And let's say, well, what lines do we actually have to worry about? Well, we have 4 lines that represent the polygon, where we have line AD, we have line AB, we have line BC, and we have line DC, right? These are the 4 sides of this square. And we want to know, okay, well, how many of those intersect with the line PQ? And so what I'm going to do first is I'm going to actually calculate the slope of all of the lines. Because, again, going way back to our discussion on perpendicular and parallel lines, right, we said that when 2 lines have the same slope, they will never intersect. So if we find that 2 lines have the same slope, we don't have to worry about them ever intersecting. Right. So let's start with PQ. Well, what is the slope of line PQ? Well, the line goes from 2, 4 to 4, 4. So because the y coordinate never changes, right, this is a horizontal line. So I don't even need to do the calculation, right? The equation for this line is going to be y equals 4. Right, so this is the same as having a slope of 0. If that didn't make sense, I encourage you to go back and rewatch the video where we talked about the equations for lines, if I went too fast through that. So let's now talk about line AD. Well, AD goes from 1, 3 to 1, 5. Because the x coordinates don't change, I know that this is a vertical line, which means it's going to have a slope of 0. It's going to be x equals 1, and it's going to have an infinite slope. Right? There is no slope. The slope is undefined for a vertical line. It's infinite. I shouldn't say it's undefined, it's infinite. So then we have line segment AB. AB goes from 1, 3 to 4, 3. And so again, this is a horizontal line with the equation y equals 3. So this would have a slope of 0. So because it has a slope of 0, right, we compare the slopes and we say a slope of 0 compared to a slope of 0 means that these two lines will never intersect. So we don't have to worry about AB. Right? So what about line BC? Well, BC is going to be going from 4, 3 to 4, 5. So again, the x values here don't change, which means this is going to be another vertical line. And it's going to have the equation x equals 4. And the slope is again going to be infinite. Again, if I'm going too fast, I encourage you to pause the video and rewatch the part you're confused about. If you're still confused, go back and rewatch the intersecting lines video and the video on the equations for lines from 2 points. So finally, we have DC. DC goes from 1, 5 to 4, 5. So again, because the y value isn't changing here, this is going to be a horizontal line with the equation y equals 5, or a slope of 0, which again, if you have the same slope, right, you're never going to intersect. So just by comparing the slope, we know that we can discard DC and AB right off the bat. So what about AD and BC? Right, their slopes are opposite. Right, I shouldn't say they're opposite. Technically, these slopes would make them perpendicular. Perpendicular. But we're not going to worry about perpendicularness right now. We just want to say, do these lines intercept each other? Well, let's look at line AD and PQ. Where would the line y equals 4 intercept the line x equals 1? Hopefully this makes sense to you, but the line y equals 4 is going to intercept the line x equals 1 at the point 1, 4. Hopefully that makes sense. So we now know that PQ and AD are going to intersect. So PQ intersects AD at 1, 4. Okay. So remembering our whole discussion on intersecting lines, right, we have to go through the work of saying, okay, well, we know what the point they intersect is, but does that actually lie in the range of our two line segments? So we have to ask the question for line AD, right? Does the x min of the line, so AD goes from x equals 1 to 1, so is 1 less than or equal to 1 less than or equal to 1? That's a yes. So this is ADX. So we have to check the y, ADY. So y, it goes from 3 to 5. So is 3 less than or equal to 4 less than or equal to 5? Again, we're just comparing the lowest y coordinate from the line to the y coordinate of the point of intersection to the highest y coordinate of the line. And we see that this checks out. So now let's do PQX and PQY. Right, so PQX, our PQ, the lowest x we have is 2, is less than or equal to the x of the point of intersection is 1, less than or equal to the x coordinate of q, which is 4. Well, wait a second. We've already failed, right? We failed right here. This is not true, right? 2 is not less than 1, which means that this whole thing fails, right? This whole thing fails. PQ does not intersect with AD. So we can cross that one off our list. Okay, so that leaves us with BC, which has a line of x equals 4, and PQ, which has a line of y equals 4. I'm going to scroll down just a little bit to give us a little more room. So just to sort of recap, we have the line y equals 4, we have the line x equals 4. These are going to intersect at the point 4, 4. Right, again, taking the y coordinate from the y line, the x coordinate from the x line to intersect at 4, 4. So hopefully that made sense. So now we're going to do the exact same check we just did. We're going to do PQ x and PQ y. So we're going to say is 1, I'm sorry, let me scroll back up so we get the right numbers. So PQ is 2, 4, Q is 4, 4. So for the x value of P, we have is 2 less than or equal to 4, less than or equal to 4, check. For the y, now we have it goes from is 4 less than or equal to 4, less than or equal to 4, check. So it's the PQ checks out, and then now we can check out the other line that we're working with, which is the line x equals 4, which is the BC. So we can do BCX and BCY. So the x coordinate of BC, right, just to scroll back up here, I know it's going around a lot, goes from, in the y direction, it goes from, in the x direction, it goes from 4 to 4. So our x is going to be is 4 less than or equal to 4, less than or equal to 4. That checks. And then in the y direction, we're going from 3 to 5, intersecting at 4. So we would do is 3 less than or equal to 4, less than or equal to 5. That checks. So because all of these checked, we can say that BC does in fact intersect PQ. So we know that we can count them up now. Did not intersect AD, did not intersect AB, intersected BC, did not intersect DC. So PQ intersected exactly one of the lines. Okay. So now we're going to scroll over here. So how many lines does PQ intersect? Well, we did all the work and we know that it intersected one line. Okay. So how many lines are to the right of our point? Ooh. How many lines are to the right of our point? And why does that matter? Well, it matters because if the number is odd, then the point is inside the polygon. If the number is even, then the point is outside the polygon. Okay, so I know there was a lot to this video. I strongly encourage you to go back, rewatch any parts you're confused about. In the next video, we're going to go through some diagrammed examples showing you exactly why the bounding box is important. We're going to get a few more complex shapes, and then why this question right? How many lines to the right of the point, why the odd means it's in, and why the even means it's out. So hopefully all of this made sense. Again, I know it was a lot. If you have any questions, please reach out. Thank you.